AE?
Yes, good. Segment AE. Good job. All right. Lily, number 15. If CF equals 14 inches, what is the diameter of the circle?
I'm trying to figure out where we are. What page are we on?
647. And we're on number 15. I'm going to jump up to Brian. Brian, if CF equals 14 inches, what is the diameter of the circle?
28 inches.
28 inches. Good. All right. Number 16. Is segment AF congruent to segment EF? Explain. Aristotle, are they congruent?
Yes, because they're both radius.
Yes, perfect. Yes, they're both radii of circle F. All right, last question there, Luke. If the distance from D to A equals 7.4 centimeters, what is EF?
3.7.
Yeah, centimeters.
Centimeters, yeah.
Okay, one more I want to do because it's going to do circumference. So turn the page and look at number 23. All right, Colby, will you read that one?
Yep. Oh wait, I can't turn my page. All right. Wait, which number? Number
23.
Okay. A bicycle has tires with a diameter of 26 inches. Find the radius and circumference of a tire. Round to the nearest hundredth if necessary.
Okay, so you'll need your calculator. If the diameter is 26, what's the radius, Colby?
I'm getting I closed my calculator back on my phone.
Okay.
All right. So diameter. So the radius would be 13 inches.
Good. And now they want to know the circumference. The circumference is pi times diameter.
Oh, wait, I did that wrong. 81.7?
Yeah, they want you to round it to the hundredth.
Oh, hundredth. 81.68
inches. Good. Yep.
inches.
So yeah, pi times 26, 81.68 inches. Okay. That's it, guys, for that section. Okay, turn to page 652. All right. Great. We have some more definitions on this page. And these are the, really, this section is the section that I didn't want you to get through geometry without looking at these definitions. A central angle. Okay, a central angle of a circle is an angle where the vertex is in the center of the circle. And the central angle contains two radii of the circle. And they show you a diagram there. Angle ABC is a central angle. If you add up all the central angles, it will equal 360 degrees. Right. So let's look at 1A. They show us three central angles, and they want to know what that third one, how many degrees it is. 1A. Grace, you can use your calculator for that, but can you figure out how many degrees angle X is?
Yeah, 50 degrees.
Good, 50 degrees. And those are all central angles. They all have their vertex in the center and contain two radii. All right, 1B. Lily, can you figure out how many degrees angle X is for 1B?
Yeah, give me a second. It would be...
Okay.
145 degrees.
Good.
145 degrees.
Yep, good. 145 degrees. Okay, so we head to the next definition below that, and it's an arc. Okay, they show you the arc. An arc is a portion of the circle defined by two endpoints. A central angle separates the circle into two arcs with measures related to the measure of the central angle. So the arc is like on the circle. Okay, so that is an arc where it's in red there, and also an arc in blue. So we have that central angle RQP, and it broke the circle up into two arcs. All right, next page, because we have minor arcs and major arcs and a semicircle. A minor arc is the shortest arc connecting the two endpoints. A major arc is the longest arc. And a semicircle is if the points lie on the diameter. All right, so a semicircle has 180 degrees in it. A major arc, you take the 360 and subtract a minor arc. So a major arc is greater than 180, and a minor arc is less than 180. Okay. So those are the things you guys have so far. Central angle, an arc, minor arc, major arc, and semicircle. Okay, let's look at example 2. Let's look at 2A. It says guided practice. Segment PM is a diameter of circle R. Identify each arc as a major arc, a minor arc, or a semicircle, and then find its measure. Okay. 2A, Brian. Arc MQ. Is that major arc, minor arc, or semicircle?
Minor arc.
It's a minor arc. Good. They want you to find the measure. We do know that PM is a diameter. Okay, so there's 180 degrees on that half of the circle. You have 115, so you have to subtract 115 from 180.
65 degrees.
Good. So arc MQ, 65. Okay. Aristotle, arc MNP. Is that major arc, minor arc, or semicircle?
Semicircle.
Good. How many degrees?
180.
Good. I guess they don't use maybe degrees. It just says the measure is 180. Okay. And Luke, arc MNQ. So start at M and then go to N and all the way around to Q.
Okay, so that's a major arc.
That's a major arc. Good. How many degrees are in that? So how you could figure that out? Well, you know that Brian was 65. I don't know if we could just subtract the 65 from 360, or you could do that angle R is vertical angle from 115. So 115 and 115. We could kind of do those, I guess. But I guess I would just take 360 and subtract what Brian said, 65. How many degrees are in arc M and Q?
295 degrees.
That's good. Okay. Below, we have congruent arcs are in the same arcs in the same or congruent circles. They have the same measure. All right. So if two arcs are in the same circle and they have the same measure, they're congruent. Go ahead and turn the page. They'll show us, they're just showing us an example of the real world, how this could be relevant when they just broke female participation up in sports and they're measuring the arcs. For that one, when they want to know the measure, it's just in percent, you know, so soccer, 14%. You just do 360 times 14%. 360 times 20%. Okay. Adjacent arcs have exactly 1 point in common. Adjacent arcs are right next to each other. There's an arc addition postulate if you add two arcs together, it equals like the whole arc that you put together. Let's see, two more definitions. We have arc length and we have a radian measure. We're going to hang on to those until tomorrow, though. So I want you to work on these arcs. So I want you to work on page 656. Numbers 1 to 9. And let's do 18 to 23. Right, page 656, 1 to 9, and 18 to 23. And before you guys leave me, I just want to do one together on page 660. Let's look at the first one. Luke, could you read that one?
Yeah. Wait, number 65?
Yeah.
A model train runs on a track with a diameter of 4 meters as shown. Which of the following is the best estimate of the distance the train travels as it moves from the station to the grain silo?
Okay. So you're estimating the distance from the station to the grain silo. So they give you those points, S for station and G for grain silo. The diameter is 4. So maybe if you would find the circumference of the whole circle and then estimate how far you think it would be from S to G. So what's the circumference of the whole circle? Pi times the diameter. So the circumference of that whole circle is what, Luke?
12.57.
Okay, good. 12.57. So the semicircle, half of it, if you went from S to the other side, would be half of that, right? So it would be like 6 point something for the semicircle, maybe about 6.25. So which would be the best estimate? They're not asking you to get it exactly, but if you were only going from S to G, and you know half of it's about 6.25, what would you estimate it to be from S to G? Go ahead, Luke.
4.4.
Yeah, good. 4.4. All right. So I will leave you guys with those questions to do page 656, 1 to 9, and 18 to 23. You guys have any questions?
Nope.
Okay. All right. Have a great day. Come see me if you have any questions. Bye.
See ya.
Thank you, Mrs. Palmer.
You're welcome. Bye-bye.